In this lesson, we want to talk about Gaussian elimination and also Gauss-Jordan elimination. All right, so over the course of the last few lessons, we've been talking about how to solve systems of linear equations in 2 variables and also 3 variables. We basically covered everything that you would see in a typical Algebra 1 and an Algebra 2 course. Now, what we're going to do is just go a little bit further, and we're going to talk about these kind of matrix methods that we can use. And we'll see a lot of these as we kind of progress through this chapter. Today, we're just going to start with Gaussian elimination and Gauss-Jordan elimination. Now, some of you saw this in Algebra 2, others didn't. I just want to assure you that this is an easy process. Most of the difficulty involved with this is just keeping track of what's going on, okay? So to begin, I'm just going to revisit this first system using the elimination method, and then we're going to go into the matrix method from there, okay? So I'm going to start out with 4x plus 16y equals 28, and 5x plus 8y equals -1. So once again, I'm just going to label this as equation 1, and this is equation 2. Now, with the elimination method, we know that our goal is to eliminate one of the variables, okay? So we want to take one pair of variable terms, okay? And we want to make the coefficients opposites. So I look at the kind of coefficients for x, I have 4 and 5. Then the coefficients for y, I have 16 and 8. So it's easier to work with y, right? Because I can basically multiply this 8 by -2, and I would have -16 there. So this would give me a -16y and a 16y, okay? So what I want to do is I want to multiply equation 2 by -2. So I'm going to multiply 5x by -2 and get -10x. I'm going to multiply 8y by -2 and get -16y. I'm going to multiply -1 by -2 and get 2. Okay, so that's my transformed equation. Again, we're always allowed to multiply any equation by the same non-zero number and preserve the solution. Now, what I'm going to do, I'm going to take my equation 1, I'm going to leave it as it is. So 4x plus 16y is equal to 28. Okay, so 2 things here before we kind of do the elimination. I want to make sure you understand that when you do the elimination method, you want to make sure that your equations are lined up properly. So in other words, I want to write everything in standard form. So ax plus by is equal to c. Okay, so ax plus by equals c, ax plus by equals c. And the reason for that is I'm adding the 2 left sides together and setting this equal to the sum of the 2 right sides. So I want to have like terms on each side, right? So when I go to add these 2 equations together, on the left sides, I have my -10x plus my 4x. That's going to give me -6x. Then over here, I have my -16y plus my 16y. And I'm going to go ahead and just cancel this, right? That's 0. And this equals 2 plus 28, which is 30, okay? So let's erase this. We already know x is going to be -5. I can complete the process by just dividing both sides by -6. And I'll just write over here that x is -5, right? 30 divided by -6 is obviously -5. Okay, so pretty easy overall. We know how to do that. And we could just plug in for x in either equation 1 or 2, find out what y is, right? Very simple. So let's just take equation 2 because the numbers involved are smaller. So 5 times -5 plus 8y equals -1. We know 5 times -5 is -25. So plus 8y equals -1. Let me add 25 to both sides. And if I add it over here, this is going to cancel. So let me just erase it. And over here, this will be 24. So let's just quickly do this. We'll divide both sides by 8. And we'll find that y is equal to 3. Okay, so very simple, very easy, something you've been doing since Algebra 1, and also for the last few lessons in this course as well. What we want to do now is think about how we could solve this using a matrix. So we're going to start out with the kind of Gaussian elimination. Okay, this is usually the first thing that you learn. And for Gaussian elimination, the very first thing you need to do is you need to set up an augmented matrix. Okay, so for an augmented matrix, I'm just going to take the numerical information only. But again, I got to make sure that these equations are written in the correct format. So I want to do ax plus by equals c. And I'll explain why this is important in a minute. But essentially, I'm just going to grab this information and I'm going to write it in the order that it appears. So I'm going to take my 4, I'm going to take my 16, and I'm going to take my 28, okay? So this row going across represents the numerical information from this equation 1, okay? So that's all that is. Then the second row that I'm going to form, which is going to be the 5, the 8, and the -1, that's the numerical information from equation 2. So the reason we want to write it in that ax plus by equals c format is that I now know that this column here, this leftmost column, that numerical information corresponds to the coefficients of the x variable. Then I know that this column here is going to be the coefficients for the y variable, and I know this column here is going to be the constants. So writing it in that manner is what allows you to know that immediately. Okay, so what I'm going to do now is I'm just going to put some brackets around this, and I'm going to put a vertical line here that's going to separate the coefficients from the constants. Okay, so this is our first step, and I'm just going to copy this now and go to a fresh sheet. Okay, so the goal is to use these what are known as elementary row operations, or sometimes you'll hear them called matrix row transformations, to put the matrix into what is known as row echelon form. Okay, so row echelon form looks like this. So we're going to have this. Let me put this, and I'm just going to use this symbol here to represent a real number. So what we're going to have is we're going to have ones starting at the upper left and going down on a diagonal. Okay, and then below it's going to be a 0 here. Okay, so I want to make this a 1 and this a 1, and I want to make this a 0. Okay, just using those row operations that I'm about to tell you. Now, these row operations are the same things we can do when we're solving a linear system with just equations, right? If we didn't have a matrix involved. So the first thing is we can interchange any two rows. So that means I could really write this matrix here by saying I have 5, 8, and -1, and then I have 4, 16, and 28. Okay, so I took the kind of second row and flipped it to the first one, took the first one and flipped it down to be the second one. This matrix represents the same linear system. Okay, it's just like if we had these two equations and I chose to write this equation 2 up on top of equation 1. That doesn't make any difference to the answer. Okay, so you can always interchange any two rows. The second thing we can do, we can multiply or divide the elements of any row by a non-zero real number. That should make sense because, again, if we go back up, we remember that we multiplied equation 2 by -2 when we were solving this, right? We can always multiply both sides of an equation by the same non-zero number and preserve the solution. So since this is just the numerical information from the equation, in other words, if I took this matrix and I multiplied row 2 by, let's say, -2, this would be -10. This would be -16, okay? And this would be +2, okay? This would be +2. And that's exactly what we saw when we were working with this kind of system, right? We multiplied equation 2 by -2, and again, we got -10x, we got -16y, and this was equal to +2. Now, the third and final elementary row operation tells us that we can replace any row of our matrix by the sum of the elements of that row and a multiple of the elements of another row. So this goes back to what we did when we looked at this. Remember, we multiplied equation 2 by -2, and then we added that to equation 1. Well, it's the same thing that we are allowed to do here, okay? It's just that we're working with the numerical information only. Okay, so let me move this over here so that we can keep in mind what we're trying to do. And let's just go ahead and start on this. This doesn't take that long. When you first start doing this, you want to use a lot of scratch paper and you want to really take your time because it's easy to make very simple mistakes on this that give you the wrong answer. All right, so the way I'm going to do this, I'm going to get a 1 for this first position here, right? Because we need a 1 there. And then once that's done, I'm going to get a 0 in this position here. Okay, so you want to finish a column at a time, working from left to right. Okay, so what I'm going to do to get a 1 there, you got to think about what's legal. Again, you can multiply a row by a non-zero real number. Well, how can I get something there that's going to be 1? 4 times what would give me 1? Remember, 4 times its reciprocal, which is 1/4, would be 1. Okay, so what I can do is I can multiply this whole row, row 1, okay, by 1/4. Now, the way I'm going to show you this, okay, is something you might see in your textbook. So you'll see this abbreviated for row 1, you'll see R with a 1 down there. So R sub 1, or you could just say R1, it doesn't matter. And that just means row 1. So I'm going to say 1/4 times row 1 is going to replace row 1. So I'm going to multiply 4 times 1/4, okay, and obviously that's going to give me 1. I'm going to multiply 16 times 1/4, and that's going to give me 4. And I'm going to multiply 28 times 1/4, and that's going to give me 7. Okay, so I'm going to replace the top row with what I just found. So let me write that right here. So I'm going to have a 1, I'm going to have a 4, and I'm going to have a 7. And then this bottom row stays the same. So 5, 8, -1. And let me close that off. And let's erase this. And we can even erase the original one. We don't need it anymore. Let's just move this up so that we have room to work. Okay, so for the next step, I want to get a 0 here, right? I've already got my 1 here, so this is done, right? So now I want my 0. So how can I get a 0? Well, this is the tricky one. It's always harder to get zeros. But basically what you want to do is multiply row 1 by something, and then add that result to row 2 so that this becomes a 0. Okay, so in other words, I've got to add something to 5 to get that to be 0. So what can I add to 5 to get a result of 0? I want to add -5, okay? And how can I get -5? Well, I would multiply 1 by -5, okay? And then add that to 5 to get my 0. That's all I need to do is multiply this top row, or row 1, okay? So row 1 times -5, and then we're going to add that to row 2. So that's all this is saying. So we're going to say that we're replacing row 2 with -5 times row 1 plus row 2. So again, when you first see this, it's a bit confusing, but after you work enough examples, it becomes pretty easy. So if I take -5 and I multiply it by everything in row 1, -5 times 1 is -5. Then 4 times -5 is -20. And then we have 7 times -5, which is -35. Okay. So I'm going to now add these values. And let me just take those results. So -5 plus 5 is 0. -20 plus 8 is -12. And -35 plus -1 is -36. So I can just replace these with those numbers. So I'm going to have a 0. I'm going to have a -12. And I'm going to have a -36. Okay. All right. So we just have one more thing to do. Okay, so I'm going to just highlight this to show that it's done. So now what I want is I want this to be a 1. Okay, so again, getting a 1 is easy because I just multiply by the reciprocal of what I want to be a 1. Okay, so I would multiply row 2 by the reciprocal of -12, which is -112. Okay, so 0 times -112 would be what? It would be 0. Okay, so this is unchanged. This equals 0. -12 times -112 is obviously 1. And then -36 times -112, we know that this cancels with this and gives me a 3. Negative times negative is positive, so this is 3. Okay, so this is 0, this is 1, okay, and this is 3. Now, at this point, we've achieved row echelon form. Okay, you have your 1s down this diagonal here, okay, and you have a 0 below. Now, this is enough information for us to get a solution for the system. Remember, this column is the coefficients for x, this column is the coefficients for y, this is the constants, okay? So here's where this comes into play. So I'm going to take this row 2, this 0, that's the coefficient for x, plus this 1, that's the coefficient for y, and this equals this 3, okay? So 0x plus 1y equals 3. What does that really tell me? 0 times x is 0, so really I have 1y or just y equals 3. So y equals 3 is part of my solution, right? If I go back up, we know y equals 3, right? So we found that part. And now what we can do is we can just back substitute and find x. So I can take this information here. This is 1x plus 4y, I know y is 3, is equal to 7. 4 times 3 is 12. If I subtract 12 away from each side of the equation, I'll find that x is equal to -5. And again, if I go back up, I see that x is -5. So again, it's not really that hard. It is a little bit time consuming when you first start because you have to figure out what's going on and you have kind of some new notation and some new concepts to wrap your head around. But once you kind of get going with this, this is a very, very quick process. Now, we talked about this Gaussian elimination in this row echelon form. There's this other related concept, which is Gauss-Jordan elimination. So what happens with Gauss-Jordan elimination is we take this a step further. Instead of there just being a 0 down here, now I would put a 0 here. Okay, so let's do that real quick. Let's transform this kind of entry here, this 4, into a 0. And what we'll see is that this gives us all the information from the matrix directly, right? We don't have to do any substituting. And this is known as reduced row echelon form, okay? So reduced row echelon form. So how can I get this to be a 0? Again, I can use row 2 here. The fact that I have a 1 there, okay? And I can say, okay, 1 times -4 would be -4. -4 plus 4 is 0. So multiply row 2 by -4. And then add the result to row 1. Okay, so this is going to give me my row 1. That's what I'm going to replace it with. So we know 0 times anything is 0, so this isn't going to change, right? I don't need to do anything for that. 1 times -4 would be -4. Then -4 plus 4 would be 0. Okay, so that's done. And then 3 times -4 would be -12. And -12 plus 7 is going to give us -5. So you see that we have our answer now directly from the matrix. Okay, very easy to read because, again, this is 1x plus 0y equals -5. Or I can say that this is x equals -5. Okay, and then this guy right here is 0x plus 1y equals 3. Or I can just say y equals 3. Okay, so directly from this matrix, I read the solution. And although it took longer for us to do it this way, that's just because we're getting started. Okay, so let's go ahead and take a look at another example. So the second example here, we have -10 equals 9y minus 10x. And we have -9x equals -4y plus 32. Okay, so the first thing we want to do, again, make sure this is written as ax plus by equals c. Okay, so for this guy over here, really all I have to do is just kind of flip it. I don't need to change anything. I can just say this is -10x plus 9y equals -10. That's perfectly legal. Then for this guy right here, I have my -9x. I'm going to add 4y to both sides of the equation, and this equals 32. Okay, so now what I want to do is just take the numerical information only. And I want to make sure I write it in the order that it comes in. So -10, 9, and -10. Then I want -9, 4, and 32. Okay, so I put my bar here to separate the coefficients from the constants, and we're ready to go. So let me copy this. We'll go to a fresh sheet. And let me paste this in here. And let me just rewrite this row echelon form. And actually, let's just use reduced row echelon form. So I want 1s down the diagonal, and I want a 0 above and below. And then over here, I'll just put this symbol here to represent 2 real numbers. Okay, and you can use letters there if that makes you more comfortable. You could say this is I and this is J. It just represents 2 real numbers. So I'll just put these symbols in here to represent that. Okay, so we're going to start out by getting a 1 in this position here. That's how I always start. And then I'll get a 0 below, and then I'll move to the right. So again, if I want to get a 1, it's really easy. Just think about what you're trying to make into a 1 and just multiply that row by the reciprocal of that. So for -10, the reciprocal is -1/10. So I'm going to multiply the entire row 1 by -1/10. So -1/10 times row 1, that's what we're going to replace row 1 with. So -1/10 times -10 would be 1. This would be 1. 9 times -1/10 would be -9/10. Okay, and then -10 times -1/10, this would cancel and give me +1. Okay, so now that I have that done, the next thing I want to do, and I'm just going to mark this off and say this is done. The next thing I want to do is get a 0 here. Okay, so I want that to be a 0. Again, not that hard because you have a 1 here. Okay, so I can just think about, I need to add a 9, a +9, to make -9 a 0. Okay, so the way I do that is I think about, okay, if I need that 9, I just multiply 9 by this whole top row. Okay, and then I add the result to the second row. So I'm going to say that I have 9 times row 1, okay, the top row, plus my row 2. This is going to give me my row 2. Okay, that's what I'm going to replace row 2 with. So let's do this down here so we can keep track of what's going on. So 9 times 1 is 9. And then -9/10 times 9 would be -81/10. So -81/10. And then 9 times 1 would be 9. Okay, so I'm going to add these to these kind of corresponding entries. So 9 plus -9, we know that's 0. So this is 0. Let's erase this. If I had -81/10 plus 4, That's going to be a bit of work. So let's do this one for a minute. 9 plus 32, we know that's 41. So let's just knock this one out real fast. And then this over here, I got to get a common denominator going. So I know this is going to be plus 40 over 10, right? If I took 4 and multiplied it by 10 over 10, I'd get 40 over 10. And now this is going to simplify to negative 41 over 10. So I'll say this is negative 41 over 10. Okay, so that part's done. Pretty easy. Now I'm just going to check this off and say that's done, and I'll move on to this one right here. I always want to get my 1 first, okay? So I want to make this into a 1. That's super easy to do. Again, I just multiply that whole row by the reciprocal of that. The reciprocal of negative 41 over 10 is negative 10 over 41, okay? That has no impact on 0. If I multiply this by this, I get 1, okay? I get 1. And if I multiply this by 41, the 41s are going to cancel, and I get negative 10, okay? I get negative 10. At this point, we have our row echelon form, right? Our Gaussian elimination is completed. But we can take it a step further again and put it in this reduced row echelon form. Again, that's from the Gauss-Jordan elimination. So what I'm going to do is I'm going to make this guy right here into a 0. And the way I can do that, again, I'm going to use this 1 right here to my advantage. I'm going to multiply row 2 by what's necessary to kind of get rid of this negative 9/10 or change it into a 0. Okay, so if I had negative 9/10, I would want to add 9/10 to make that 0. So I'm going to multiply row 2 by 9/10. So 9/10 times row 2, add the result to row 1. Again, I just use this symbol to say, hey, I'm going to replace row 1 with 9/10 times row 2 plus row 1. Okay, so let's go ahead and do that. So I know that 9/10 times 0 is 0, and 0 plus 1 is still 1. Okay, so that's no change. And then 1 times 9/10 is 9/10. 9/10 plus negative 9/10 is 0. So we've got that. And then for this last one here, I'm going to have 9/10 times negative 10, which the 10s are going to cancel. It's going to give me a negative 1. So this would be negative 9. Okay, negative 9. And then I'm going to add the result to this row 1. So negative 9 plus 1 is negative 8. Okay, so this is negative 8. And we don't need to do any substituting. We already can just look at this and know our answer. We can say that 1x plus 0y equals negative 8, or we can basically say x equals negative 8. And we can say that 0x plus 1y equals negative 10, or just y is equal to negative 10. Okay, so again, not as quick as we're used to, but just because we're getting this kind of process started, once you really get going with this, you can do this very, very quickly. All right, let's take a look at one more of these, and then I'll show you the kind of special case scenarios and what happens with those. So we have 12x equals negative 11y plus 20, and then 12y equals 15x plus 78. So again, what I want to do is I want to start by writing everything in the format of ax plus by is equal to c. Okay, so over here, I have 12x. I'm just going to add 11y to both sides, and this will be equal to 20. Over here, I'm going to subtract 15x away from both sides, and then plus 12y, and this will be equal to 78. Now, one thing you want to do, if you notice that everything in an equation is divisible by some number, you want to take the opportunity to simplify it because it's going to make your calculations easier. So if I look at this second equation or this bottom equation, everything's divisible by 3. This would be negative 5. This would be 4. And this would be 26. Right? I just divided every part of that equation by 3. That's something you definitely want to do because it's going to make it easier to achieve your answer. Okay, so let's scroll down just a little bit. I'll set up this matrix. So again, just take the numerical information. So 12 and negative 5, 11 and then 4, and then you have 20 and then 26. Okay, so let's go ahead and copy this. And again, what we're trying to do is get this reduced row echelon form. So 1's down the diagonal and a 0 above and below. And then over here, we're just going to have real numbers. Okay, again, this is reduced row echelon form. And once more, if you have a number here, then it's row echelon form. Okay, so let's get started again by making this into a 1. Very easy to do. We're just going to multiply the top row by, again, the reciprocal of that number. The reciprocal of 12 is 1 over 12. So again, I'll write this as 1/12 times row 1. That's what we're going to replace row 1 with. So this would be 1. 11 times 1 over 12 is 11 twelfths. So 11 twelfths. 20 divided by 12, let's write that over here. 20 divided by 12, each is divisible by 4. So this would be 5 and this would be 3. Okay, so this would be 5 thirds. So 5 thirds. Okay, so now I want to get a 0 here. Let me kind of highlight that to show that it's done. I want to get a 0 here. So again, if I have -5, I know that if I add 5 to that, I'd get 0. So I'm going to multiply row 1 by 5, add the result to row 2. So 5 times row 1 plus row 2, that's what I'm going to replace row 2 with. So 1 times 5 is 5. 5 plus -5 is 0. Okay. And then 11 twelfths times 5, we know this would be what? This would be 55 twelfths. So 55 twelfths. And then plus 4. To get a common denominator, I'd say this is 48 twelfths. So what's 55 plus 48? That's going to be 103. Okay, so this would be 103 twelfths. 103 twelfths. Okay. And then for this guy right here, again, we have 5 times 5 thirds. 5 times 5 thirds, so that's 25 thirds. And then I'm going to add that to 26. Again, 26 times 3 is 78, so I could say this is 78 thirds. And 25 plus 78 is 103. So you get 103 over 3. Okay, so let's erase this, and I'll mark this one as done. And now I want to get a 1 here. Okay, I want to get a 1 here. So again, that's very easy to do. We're going to multiply row 2 by the reciprocal of this number. So I'm going to have 12 over 103, okay, times row 2. Again, I'm going to replace row 2 with that. So I know that 0 stays unchanged because 0 times anything is just 0. And then this guy would be transformed into a 1. And then this guy, I would have what? I would have 103 over 3 times 12 over 103. So we know this would cancel with this, and this divided by this would be 4. So I can erase this and just put a 4 here. So again, at this point, I have my row echelon form. So if I wanted to go back and substitute, I could find my answer at this point and I'd be done. But I like to take it to this form where this guy right here is a 0 as well. And I can just read my answer straight from the matrix. So how can I get a 0 here? Again, I want to think about what can I add to 11 twelfths to make it 0? What would be a negative 11 twelfths? And so I would just multiply row 2 by a negative 11 twelfths and add the result to row 1. So I'm going to multiply negative 11 twelfths times row 2, add the result to row 1. Okay, that's how I'm going to get my row 1. Okay, that's what I'm going to replace it with. Okay, so negative 11 twelfths times 0, I know is 0. 0 plus 1 is still 1. No change there. Then negative 11 twelfths times 1 is negative 11 twelfths. Then plus 11 twelfths is 0. So that's what we want there. And then negative 11 twelfths times 4. This cancels with this and gives me a 3. So I'd have negative 11 thirds. And then I'm going to add this to 5 thirds. So negative 11 plus 5 is going to be negative 6. So this would be negative 6 thirds, which is negative 2. So this is negative 2. And again, we found our answer. So we know that at this point, what? X is equal to negative 2. X is negative 2. And Y is 4. Now let me show you what happens when you have a special case scenario. Again, you know that you have systems that have no solution, and you know you have systems with an infinite number of solutions. Again, if you end up with kind of a false statement, then you know you have no solution. If you end up with just a true statement, you know that you have an infinite number of solutions. So let's go ahead and start this in the usual way. I'm going to have a negative x. I'm going to subtract 3y away from each side, and I'm going to subtract 1 away from each side. And then over here, I'm just going to flip this and say this is 8x plus 24y is equal to 17. Again, that's perfectly legal. So the numerical information from this, I'm just going to take a negative 1, a negative 3, and a negative 1, and then an 8, a 24, and a 17. Okay? So we're good to go with this. Let me just copy this, and I'll paste it in right here for us. And again, I'm trying to achieve this form. 1's down the diagonal, a 0 above and below. Again, this is reduced row echelon form. And then these will just be numbers over here. And once more, just so we don't forget, if this is just a number over here and it's not a 0, then this is row echelon form. Okay, so that's the difference between the two. It's something you might get asked about, okay, on a test. They might tell you to put it in row echelon form, or they might say put it in reduced row echelon form, and you need to know the difference between the two. Okay, so I want to get a 1 as the first entry right here. How can I do that? Again, we've been doing this all day now, so I'm just going to multiply row 1 by the reciprocal of that number, okay? So negative 1 is the reciprocal of negative 1, right? Because if I wrote this over 1, I would say that the reciprocal of it is 1 over negative 1. Again, it's just negative 1. So I would say that we have negative 1 times row 1. That's what I'm going to replace row 1 with. So negative 1 times negative 1 is 1. Negative 1 times negative 3 is 3. Negative 1 times negative 1 is 1. Okay. So now what I want to do is get a 0 here. So how can I do that? Again, we've been doing this all day. I know I need to add a negative 8 to 8 to get 0. So I'm going to multiply row 1 by negative 8. Okay, so row 1 times negative 8. I'm going to add the result to row 2. Again, this is going to give me my row 2. All right, so negative 8 times 1 is negative 8. Negative 8 plus 8 is 0. Then negative 8 times 3 is negative 24. Negative 24 plus 24 is 0. Should already see that there's a problem. And then let's just keep going. Although you know there's no solution at this point, just keep going. Negative 8 times 1 is negative 8. Negative 8 plus 17 is 9, okay, is 9. So let's stop for a minute and consider what we have. We have 0x plus 0y equals 9. So 0x plus 0y equals 9. What is 0x? It's 0. What is 0y? It's 0. So basically you have 0 plus 0, which is 0, equals 9, which is always false. So this is no solution, okay? And if we went back and we really observe this, we would see that we have two lines that are parallel, or two lines that have the same slope. If I just look at this as 3y equals, you have negative x plus 1. Again, divide everything by 3 to put it in slope-intercept form. And the slope here is going to be negative 1/3, okay? For this one, let me write this as 24y. 24y is equal to negative 8x plus 17. I'm going to divide everything by 24. And you can already see that you have the same slope, right? You can erase this. Negative 8 over 24 is negative 1/3. Okay, negative 1/3. And then 17 over 24, you can't simplify that, but you don't need to because you can see that this slope and this slope, those are the same. When we have parallel lines, again, we know that they don't ever intersect. So there's no point that lies on both lines. So there's no solution for the system. Okay, so this guy right here, you can put the symbol for the null or empty set, or again, just write no solution. Let's look at one more problem just to kind of wrap this up. And then in the next lesson, we'll look at some systems with 3 variables. So now we have negative 1 equals 2x plus 5y. So I just have to flip this. So 2x plus 5y equals negative 1. And then for this one, I have negative 6x minus 15y equals 3. So we're good to go at this point. But before we even start, you can immediately notice that what? If I multiply equation 1, or this top equation, by negative 3, I get equation 2. Okay? 2x times negative 3 is negative 6x. 5y times negative 3 is negative 15y. Negative 1 times negative 3 is positive 3. So you know that this is going to be an infinite number of solutions for the answer, okay? Because these two equations are the same. So whatever works in the first equation also works in the second equation. Now, let's show this with a matrix. We have 2, 5, and negative 1. And then we have negative 6, negative 15, and 3. So let's copy this. So again, I'm looking to get this kind of reduced row echelon form. So 1's down the diagonal, a 0 above and below. And then these are just numbers, okay? So I'm going to get a 1 here in this first position. We already know what we're doing. Multiply row 1 by 1/2, which is the reciprocal of 2. So 1/2 times row 1. That's what I'm going to replace row 1 with. So this would be 1. This would be 5/2. Okay, this would be 5/2. And this would be negative 1/2. So this would be negative 1/2. Now for this guy right here, I want to make this into a 0. And to do that, I'm just going to multiply row 1 by 6, add the result to row 2. So I'm going to multiply again row 1 by 6, add the result to row 2. So that's what I'm going to replace row 2 with. So 6 times 1 is 6. 6 plus negative 6 is 0. Okay. Then 5 halves times 6. This cancels and gives me 3. 3 times 5 is 15. 15 plus negative 15 is 0. Negative 1 half times 6. The 6 cancels with the 2 and gives me 3. Negative 1 times 3 would be negative 3. So I would have negative 3 plus 3, which is 0. So again, I'm going to end up with 0 equals 0, which is always true. So that's how I know I have an infinite number of solutions. So let's just write that out. We have an infinite number of solutions.